All right, now we're going to start a new topic, similarity. And so this is going to be, this is actually a new chapter, a new section. And so we're going to introduce the topic of similarity, but before we're going to review something we talked about before. We said in a previous video, previous chapter, we said that H and H hat are equivalent, are matrix equivalent if there were non-singular matrices P and Q such that this relationship holds. Okay, and we were motivated by this diagram here where we had two matrices, H and H hat, that both represented the mapping H, but to different bases. Okay, and but now what we're going to do is we're going to consider the special case of transformations where the codomain and the domain are the same, and we're also going to add the requirement that the codomain's basis equals the domain's basis. And so we're going to be considering this representation here now, where we're going to have two different matrices T and T hat that represent the mapping T, but again we're going to the same basis. So basis B and basis D are the same. And we're also, again, we're staying within the same, vector space. Okay? And we're going to represent it using the matrix representations here. So the representation of D and D of T equals this here, where we're going to have a representation with respect to B and D of the identity mapping composed with the representation of with respect to B and B of T times the inverse of this representation here. And that's where we're starting, and we're going to start with definitions and examples, and we'll go from there.